All right, guys, let's get into these problems. We'll start number one and see how it goes from there. Let's see. All right. So first thing we want to understand is our job for these problems is one, we're going to regraph this given this information. Then after we graph it, we are going to write the equation for the new graph, okay? So first thing we have to understand is this graph, as you see in the directions, is called f of x, okay? So think of this as its name. So this graph name is function f, okay? So function f, we are going to translate. Translate is just a fancy way of saying move. We're going to move this graph 4 units to the right and 3 units up, okay? So what you want to do here is look at some significant points in our graph. So I'll put these in red. So we got this is a significant point, that's a significant point, and this is a significant point. So these are 3 points, and what I'm going to do is essentially do the movements of these 3 points, and I'm going to do it for all 3 points. And once I do these movements, it's going to give me my new graph, which we are going to call g of x, or function g. Okay, so let's do it. So the first thing I want to do is I'm going to move the graph 4 units to the right and 3 units up. So 4 units to the right and then 3 units up. So I'm going to do that for every point. So let's start here. 4 units to the right. 1, 2, 3, 4. And then we're going to go 3 units up. 1, 2, 3. Okay. This is now going to be, this dot has moved to this location. So I'm going to put my new dot here. Okay, so again, this dot has moved here. I'm going to do the same thing here. 4 units to the right, 3 units up. So let's do it. 1, 2, 3, 4. And then we're going to go 3 units up. 1, 2, 3. So my second dot goes here. And we'll do it for the last dot. 4 units to the right. 1, 2, 3, 4. 1, 2, 3. 3 units up and put my dot here. Okay, now I'm just going to graph these guys by connecting them. And what you'll notice is you essentially have the same graph that has been translated or moved. This new graph we're going to call function g. So we name it g of x. Okay? So we're done with 1a. So this is 1a. This is the answer to 1a. Now we're going to go 1b. Write g of x in terms of f of x. So if you watched the video from Monday, you know that every graph that's translated has an h and a k. So let me write this out. So if we have a graph, we'll call it f. Every graph has an h and a k. Okay? So what does that mean? It means we are going to figure out what our h and k is. So as a reminder, again, watch the video from Monday. As a reminder, we know that our h is our left and right shift. Okay? Our k is our up and down shift. So essentially, if you look at what we have done, our graph, if example 1, is we went 4 units to the right. So 4, since it's moving to the right, is going to be positive 4, okay? So in this case, my h, when I plug it in, is going to be 4. And then my k when we move units up, this essentially is my k. So my k is going to be positive 3. So now that we have our h, remember our h is our left and right shift, our k is our up and down shift. I'm just going to plug it in to h and k here. So my h is positive 4. So again, this negative is part of the graph or part of the formula. So we're just going to replace h with 4. Okay, so we throw it in there. It's now 4. My k is my up and down shift. So since we shifted up 3, it's going to be positive 3 for my k. Okay, and again, we've taken the function f and we did these shifts to them. So we have to rename this. This is now the equation for function g. So essentially, g of x, which is this guy, takes function f and does these shifts to it, does the h and k. So this would be my equation for example B. All right. So just so we can get this going, this is the answer for 1A here. All right, because we have, using the same graph, we have an answer for 2A. So let's do 2A really quick. So 2A, we're going to take our original graph, okay, F, and translate the graph 1 unit to the left. All right, so we'll do this in a different color, but we're going to go 1 unit to the left for all these dots. We're going to go 1 unit to the left, and we'll put a dot here. 1 unit to the left, put a dot here. 1 unit to the left, put a dot there. Now connect those. Again, it's only a shift to the left. We have no vertical shift. So we have this. Okay, this is our part 2 problem. So this is, we'll call this g of x again. Okay, and this is for problem number 2a. This is the answer for 2a. All right, so let's write our function in terms of g of x. So again, we have f x minus h plus k. So we have to fill in the h and k. So the h is our shifts left and right. So left and right shift. K is up and down. So if you look, we have 1 unit to the left. So since we shift to the left, it's going to be a negative number because we're shifting backwards, if that makes sense. And then our K unit is, are we shifting up or down? And the answer is there is no shifts up or down, so it's going to be 0. All right, so we're going to take these two, plug it into our function. So it looks like this. So instead of h, we're plugging in -1. Okay, instead of k, we're plugging in 0. So as you can see, I have to clean this up a little bit because 2 negatives make a positive. So we're going to have f of x plus 1. And do we need a 0? Nope. When we add 0, we can just kind of not write it. Okay? So this is my function for g of x. Okay? All right, I'll let you go ahead and do 3 and 4, but real quick, remember you kind of want to find significant points in your graph. So I have a significant point here, here, and here. And I'll shift those according to how it says to shift. Okay? Let's jump over to number 5. So 5, they give us the shifts. They give us the graphs. So we have to describe the shift. So to describe the shift, we start from f of x. So we're starting here to g of x. So taking f of x, again, I'm going to use significant points. And all I want to know is, essentially, I want to know my h and my k. All right? So again, your h controls left and right shift. Your k controls up and down shift. Okay? So we're going to go from f of x, according to this, how do I get to g of x? Okay? So I'm going to use this point. And again, if you do 1 point, you're pretty much good. You don't have to do all three, because if it works for one, it will work for the other three. All right? So I want to know, do I have to shift left or right to get from this point to its matching point in g of x? So let's go here. So as you can see, it's pretty obvious. We're going to shift 1, 2, 3, 4. So we're shifting to the left 4. Okay? So shift left 4. Okay? Which means my h value, since we're shifting left, is going to be negative 4. All right, once we shift left 4, do we have to shift up or down to get to my final destination? The answer is we're going to shift up. Okay, so that's going to be a shift up. And we're shifting up 3. Okay, and it's positive because we're going up, so that's going to be a k value of positive 3. And now we are going to write this in equation format. So our original graph was f, and we changed it using h and k. Okay, so all we're going to do is plug in the h, plug in the k, and we're good to go. So my h value in this case is negative 4. My k value is positive 3. And now clean this up if you need to, which we do. We got to clean the two negatives up here. They turn to positive, so it's f x plus 4 plus 3. And this is my equation for g of x. So to get g of x, I had to change f of x using h and k. That's why it's written like this. Okay? Again, if you notice, I only used 1 point. If you want, you can check the other points, but they'll do the same thing. So for example, really quick, from this point to this point, I have to go backwards 4. 1, 2, 3, 4, up 3. 1, 2, 3. It works. Now this point to this point, back 4. 1, 2, 3, 4, up 3. 1, 2, 3. Okay. I'll let you go ahead and try 6A. Let's go ahead. I'll do 7A, 7B. Okay, so using this graph now, we have a circle. Okay, so these are circle graphs. I want to shift from f of x, so this guy, to g of x, this guy. Okay, so let's pick a significant point on the circle. I'm going to pick this point at the top. Put a little dot here, which means I need to pick this point at the top and see how I shift from the f of x point to the g of x point. Okay, so I want to do left and right shift first. So I'm going to go left, 1, 2. So let's write that down. Shift left twice or 2 times. Okay, which is going to be my h value. Since I'm shifting left, that's negative 2. And then I have to shift up. 1, 2, 3, 4. I'm going to shift up 4. That's going to be my k value. Shift up 4. So my k value is positive 4. Again, if you shift down, it's negative. Okay, so k value can be negative. So there it is. I got my h and k. Now I want to write it in terms of my h function or my f function. Okay, so this is going to be my g of x function once I plug in my h and k. So again, I took my f function and I'm going to shift it using h and k, and when I shift it, it's actually going to turn into my g of x function. So let's plug this in. My h gets plugged in here. That's going to be plugged in with -2. My k is 4, positive, so +4 there. And clean this up if you need to. So it's going to be f of x plus 2 plus 4, and this is going to be my g of x. Okay, I'll let you go ahead and try number 8, A and B as well. Okay guys, these problems here, if you haven't seen the video from Monday, you are maybe a little lost as I go through these, okay? Very important that you watch the video from Monday because it talks about something called the parent graph or the original graph, okay? Each one of these, as you notice, each one of these graphs are shaped differently. These two are kind of the same, okay? But these are shaped differently. Because of that, each one of these have a different parent graph, or think of it as your original graph, okay? So these graphs have an original graph, but these graphs have now been shifted, okay? So what I'm going to do is I'm going to graph the original graph, okay? And then I'm going to give you the original equation for the graph, all right? So this first one is called the absolute value graph, and it has original points. Anytime you have an absolute value equation, it always has this shape. So this graph that I'm drawing in here is the original, or what we call the parent graph, okay? So think of it this way. This was your starting graph. It has now been shifted to this graph, okay? How do I get my starting graph? This is something I have memorized, but it's explained in Monday's notes, okay? The equation for this guy, we'll call it F. The equation for absolute value graphs is this. It has the absolute value of x, okay? So this equation is for this graph, all right? Let's go to number 10 before we start answering these, okay? So number 10, this is called a cubic. I should write these down. So this is absolute value. This, when you see this snake-looking shape, this is called a cubic. Okay, that's the name of the graph and the equation. So this is not the original cubic. The original cubic has these original points. It starts here, 0, 0, just like this, but it has this curve to it, okay? So this is the original cubic. All right, so this original graph has been shifted somehow, and that's what we're going to find out in a little bit, okay? The equation for the original cubic is when you see x to the power of 3. If you see any equation with a power of 3, x to the power of 3, you're going to have this shape, okay? Just like when you see any equation with absolute value, you're going to have the V shape. All right, this is all explained on Monday's video. This problem number 11 here is called the quadratic. You might recognize this from IM2. So this is called the quadratic function or quadratic equation. The original quadratic has a U shape, but the original, the parent graph, starts at 0, 0, just like all the other ones do. You should start noticing they all start from 0, 0. So it has these points. Okay, so this is my original graph. All right. The equation for this original graph is when you see a function that has x to the power of 2, its graph is going to have this U shape. Okay? This one here is the same shape as this. So I'm not going to draw the original again, but it would have the same original here. Actually, let's draw it because we're going to need it. This is absolute value because it has the V-shaped. Okay, so now, what is this asking us to do? Well, it's asking us, can you write the equation for each graph? So we want to write the equation for this. So since this is no longer in the original spot, something has changed. And in essence, it has shifted. So we'll call this guy g of x, because it's no longer f of x was the original name, but now it's a new graph, so we're going to call it g of x. So we know g of x, since it has the V shape, we know it has to have absolute values. So we write it in as absolute value, but since it's shifted, as you can see, it's moved. As you learned earlier in Monday's notes, you move using the H and the K. All right? So we have to figure out, how did I shift? I'm letting everybody know at the absolute value, I have a V shape. That's what the absolute value means. But I'm also letting everybody know I shifted somehow. Okay, so we're going to use our original, which is in red. How did I get my original? Please watch Monday's notes. Okay, it shows you where they come from. All right, so I'm going to do left and right shift. So how do I get from this significant point to its matching point in g of x? So it's pretty easy. We just got to count. So we got to go 1, 2, 3, 4. So I shifted to the right 4. And remember, H is your shifting. So since I'm shifting to the right, it's positive 4. And then I'm shifting down 3. K is my up and down shift. So that means I'm going to shift down 3, which is a negative 3. Once I have my H and K, I can plug it into here. Okay? And that gives me my new equation. So we have G of X, because that's what I named it, equals to, we have the absolute value graph, so we got to put the absolute value. X doesn't change. That's letting everybody know we have absolute value shape. Now my H, again, this is part of the equation, so it's always negative. And then we're plugging in 4. Okay, for H, there's no double negative, so I don't have to clean anything up like we did earlier. And then my K is going to be minus 3. So I plugged in negative 3. This is the equation for G. So it basically says I had an original absolute value graph. So this is my original. And I shifted I shifted right 4 and down 3. Okay? Just plug it in. Same thing happens here. We have a cubic. So when I do my new graph, we use the same idea. So we're going to have X minus H. Now instead of absolute value, it's going to be using cubes. The H, when we do shifts, H always goes with the X. It'll either be inside parentheses, or when we use absolute value, is going to be inside the absolute value like we did here. Okay? And then our K always goes in the outside. So all we got to do is figure out our H and K again. How do I know this equation? Because it's a cubic. We just added in the h and k. All right. The power 3 goes on the outside of the x and h together. X and h will always be together like this. All right. So let's see. I want to go from my original point to my new point. So basically this point to this point right here. So how many shifts do I do? 1, 2. So I went backwards 2. So that's shifting -2. And then do I have to shift up or down? And the answer is no. So that means my up or down shift is 0. And now I essentially just plug this in here and this in here. Again, watch the Monday video if you're trying to figure out where the heck you get these equations from. It's all in Monday's video. All right, so now let's write this. So we have g of x equals x minus for the equation. But then I have a -2 as well. That's my h to the power 3. It's a power 3 because we have a cubic shape. And then my k is +0. So let's clean this up. X minus -2, that's going to be x plus 2, power of 3. And then we don't need to write this +0 because it really doesn't do anything. So my equation for this is g of x. Okay. All right. Same thing here. We have a quadratic, x squared. So my new graph, if we have shifts, my new graph, we'll call it g of x again, is going to have x squared, but we got to put in our h and k. So notice, this is pretty much a template for all our graphs. The only thing that's really changing is the power. In this case, instead of parentheses, absolute value is used, okay? So let's find our h and k again. H. Okay, so let's go from our original graph. I'm going to use this significant point and match it to its other significant point here. So let's shift. We're going to shift to the right 1, 2, 3. So I shifted to the right. That means my h is +3. And then I'm going to shift down 1, 2, 3, which means my k is -3 because I'm going down. Plug this in here and here, and we are done. So g of x equals x minus, and then we're plugging in 3 for h squared because it's a quadratic, and then plug in k, but we're not doing positive k because we have a -3 for k, so it's -3 here. Nothing to clean up. This is my equation. All right. So we notice this is absolute value. So my new graph is going to have the absolute value in it. So absolute value, we have a shift. So we set it up like this. Now we just got to find our h and k using, basically we're counting. So how do I get from my original to my new? Original to new. So if you look, I do not shift left to right. So that means my h is 0, but I do shift down 1, 2. So that means my k is -2. Let's plug it in here. So g of x equals x minus 0, oops, absolute value, and then -2 for k. Okay. If you notice, we don't need x minus 0. You can actually do that math. X minus 0 is just going to give me x. So my real equation, we'll put it here. G of x is equal to absolute value of x, because a 0 doesn't do anything, and then -2. Okay, so again, if you're confused on where do I get these functions, these equations, and these original points, watch the video from Monday. All right, guys, let's go ahead and get you out of here. I'll give you the check-in code, and then if you have any questions, stay on.